Hey guys, Justina Orozco here, and today we're going to be going over logarithm and LNs and all these things, Euler's number. So to begin, we're going to go over with something that really helped me a lot, and YouTube even helped me with this too. So for any type of log function equation, so the base raised to what power, which is p, equals a number, and so that a number is going to be our missing number, what we're looking for. So to put it into perspective, log b to the base to I'm putting here b, so what power to b equals a number. It kind of just rotates around. This is typically what we're going to be looking for. So again, we're going to ask ourselves the base raised to what power equals a number. So to begin to, also my favorite color is green. I really love this coffee. I think it's so good. If you're ever at Target, you should try it. Or if you live near Oregon, near Portland, Oregon to be exact, Stumptown is a great roasters. There, I tried it in Oregon, and now I have it here in Texas because of Target. So I love this green, all things neutral colors. Even this orange is pretty nice in my shirt color. But to begin, we're going to start with our problem A. So log 3 to the 27. Again, 3 to what power equals 27? So again here, we're going to look through 3 to what power equals 27? Well, we know 3 to the third equals 27. So so we know 3 to the third equals 27. So the exponent that we're missing, 3, that's going to be our answer, because again, we're looking for that missing number on our chart. This was our 3, so that's our missing number. So the answer to that one is 3. B is going to be log to the 27 to the 3. So again, we're going to ask ourselves, what 27 to what power equals 3? Well, again, we know 3 to the third power equals 27, but we need to know what equals 3. So 3 to 0, but because we need a number, it's going to turn into the fraction right here, 1 over 3. So again, we know 3 to the third is going to equal to 27. Now we're looking for 27, which is going to give us that fraction 1 over 3. All right, then we're going to look for our third question. Just see, so log what the base 9, parentheses 1 over 81. So I'm saying base because if you can also look right here, anytime we're looking at a log system function equation, that lower number is going to be your base, and that top number is going to be your arguments. So again, we're looking here. So 9 to 1 over 81, logarithm base 9 of 1 over 81 is going to be -2. So even if we put those, so 9 over 81, that's going to simplify to that 1 over 81. Now what do we get? 9, that's going to become from 3 to the third power is equal to, 3 to the second power. 3 to the second power is going to give us that 9. So now that we have this 9, okay, that number, that -2 that's how we got the -2, because 3 to the -2 power equals 9. 9 is right here. 9 to 1 over 81 simplified is going to be 1 to 81. All right, then question D, ln 3 over e. Our answer is going to be 1. So for Euler's number, it's a mathematical constant represented by letter E, what is the base of a natural logarithm and is used in problems relating to an exponential growth or decay. So if we look here, E is going to equal to 2.718. And if we look here, we kind of have a chart set. ln parentheses E, and anytime we look at that, E to what is going to give us, as E to E is going to give us 1. So if we look here, E to the third, our third is already our powers, but E to the what is going to give us E. E to the 1 is going to give us E. Complicated because it has a lot of numbers, but there it is. All right, log to 10, logarithm base 10 of 10 is 1. So again, because we don't have anything, but we know 10 to the 1 is going to give us 10, then it's just going to be back to 1. All right, so these next couple of questions, they all equal 0, and there's a particular reason why they all equal 0, and it's simply because of their base number, not their base number, their I guess their powered number is all one. So all of these have a 1 in them. 1, 1, 1, 1. And so anytime anything logged 1, so anything logged 1 to 1 is 0 because the number to the exponents 0 equals 1. So right here I have this written down. Anything logged 1. So first one is going to be ln to the 1. The natural logarithm of 1 is 0. And the way we can see that is because of e. So anytime this is here, and I even have this written down, that ln is going to turn into the e. So anytime we have ln 1, e to what equals 1? 0. That's why we have that. And then we already have our 1 here. We're going to go to here, so g. Go down to g, log 1. So anytime we're looking, again, for anything that's 1, we're going to be looking, okay, what number to this power is going to give us 1? So 10 to this 0 power is going to give us 1, but our 0 was our missing number. So it's 0. We'll go down to h. Log 3 to the 1. Again, these are all have 1, so they're all going to equal 0 because 3 to the exponent 0, or to the 0 power, is going to equal to 1. Again, this right here, this is our missing number right here. So now we're looking for these relations. 3 to the what's going to give us 1? 0. Same thing here. Log 50, even if it was a big number. So 50 to the exponent 0 is going to give us 1. Again, just because we're looking for our missing numbers here. What's going to give us 1? 0. 50 to the exponent. See those? Okay, and then our last question is going to be ln parentheses 1 over e parentheses. Again, anytime that e comes up, it's going to give us, we're dealing with this number 2.718, but if it's in a logarithm, it's going to turn into a negative. So basically what gives us 1, e, is going to be ln multiplied, or parentheses negative 1, and therefore that was our missing number, so it's going to be negative 1. I hope this helped. Even this little graph has helped me quite a bit, because I'm looking at what is my base. What does my base need to equal that powered number? What exponent needs to equal this powered number? Again, so anytime you're looking at that, what does this equals this? Whatever you get this is you already have these two, so now you're kind of just always looking for this exponent. So what does 4 give me to equal 64? That's just an example. Again, they're all just going around. Alright guys, I hope that helped. Have a phenomenal day and a phenomenal week. Please comment, let me down know if there's any questions or comments or concerns. Love to help.